Hello everyone, Principal Sylvester here with another video. This time we're going to focus on exponents. As we continue to work on mastering PEMDAS, exponent is the key part that we have to also master. Exponent is going to lead to other important chapters that you will have to learn, like scientific notation and doing arithmetic with scientific notation. Before we continue, let's review last week's challenge. This right here is a challenge problem where I wanted you guys to use PEMDAS to solve, simplify this expression. Remember, PEMDAS is our roadmap. All right. So if we start with PEMDAS, we know that parentheses comes first. Now, once you see the parentheses, you know that there are multiple operations within this parentheses, which means that you have to follow PEMDAS once more. I have 4 plus 5 times 2. According to PEMDAS, we know that multiplication comes before addition. Therefore, as I target this part of this expression, I'm going to make sure that I keep applying PEMDAS to simplify it further. If you take a look here, we know that 5 times 2 is 10, and we know that 4 plus 10 is 14. Once we finish with all the operation within the parentheses drops. All right, so now we just have 14 outside of the parentheses. We do not need the parentheses anymore. Those operations were already completed. Now we focus on the larger expression. And once again, we apply PEMDAS. We could apply PEMDAS as often as we want. Now over here, you see that you have 16 times 5 divided by 14 plus 3. Now remember, multiplication and division are interchangeable, so I'm going to move from left to right. All right, we know that 16 times 5 is 80. 80 divided by 14 plus 3. Now, we know that we do not get a whole number when you divide 80 by 14. Usually when I'm doing long division, we are going to be rounding to the nearest hundredth. Therefore, when I divide 80 by 14, I end up with 5.71. All right, or 5 and 71 hundredths. Now, if you still need help with that, with place values, that is a different video that we are going to create to make sure that you understand the basics of place value. Now, if you notice, you have 5 and 71 hundredths plus 3. In order for me to match them when I'm doing my addition, I am going to add 2 decimal points to 3 and 2 additional zeros. This is just so they can line up perfectly. And then once I do the addition, I know that 1 plus 0 is 1, 7 plus 0 is 7, and then 5 plus 3 is 8. There's a reason why I chose this problem, and there's a reason why I wanted you to see that a whole number could be adjusted to satisfy the problems that you're working with. All right, so as we continue to dive on exponents, you're going to see specifically why this is able to happen and why it's important to understand it. All right, back to exponents. What are exponents? All right, exponents are repeated multiplication of the same number or symbol, which we're going to call the base. All right, so if you look at this example, you have 5 with an exponent of 3. The number 5 is the base. Keep that in mind. Every time we refer to the base, we refer to the number or symbol that is not the exponent. Now, the number 3, this is called a superscript when you are writing. The superscript is the exponent, which basically tells the base the amount of time it should be multiplied by itself. In this case, my exponent is 3, which is telling my base of 5 to multiply itself 3 times. So I end up with 5 times 5 times 5. Now, this is the key point that I was trying to make in the challenge questions. Numbers adapt. Now, what does that mean? It means that they adjust to their surroundings. So if you take a look at the number 5, if I'm dealing with decimals, 5 becomes 5.00, depending how many place values I need to include. If I'm dealing with fractions, the number 5 becomes 5 over 1. All right. That way it adapts to the fraction problems that you're dealing with. And now if I'm dealing with exponents, the number 5 becomes 5 raised to the 1 power. All right. In this case, 5 to the 1 is still equals to 5. But we have to make sure that numbers adapt. And we have to start thinking of this adaptation whenever we're dealing with different type of operations. Because again, numbers are able to adapt to whatever operations we are dealing with. It will help you in any situation that we deal with moving forward. All right. Also, exponents. Exponents can be any real number. All right, that means any number. Exponent could be any numbers. It could be positive numbers, negative numbers, decimals, fractions. However, each set of numbers have a different effect on the base. All right, some of their own, and they also have some of their own distinctive names. It all depends what you're dealing with. But keep in mind that exponents could be any real number. All right, this is just a quick practice. I know we're introducing exponent, but this is a quick practice. If you take a look at these three problems, we have my base of 3 is being multiplied a certain amount of time by itself. My base of 7 is being multiplied a certain amount by itself. My base of A, my variable A, is being multiplied by itself a certain numbers of time. So take a second, pause the video, complete this on your own. All right, hope you guys did well. So basically, if you take a look at the first problem, my base is equal to 3. My exponent is equal to 4, and that becomes 3 to the 4th power. If you take a look at the second problem, you have the base of 7, the exponent of 3, so therefore my number is 7 to the 3rd power. And then if you take a look at the last example, my base is the variable A, the exponent, it repeats itself 5 times, therefore my exponent is 5, so the number is 8, or the value is 8 to the 5th power. All right, so again, exponents tell the base how many times it has to multiply by it, if that has to be multiplied by itself. Now, power. Power is a new concept that we are going to use with exponents. All natural numbers are numbers from 1 all the way to infinity. 1 all the way to you could count. All right. So those exponents are called power. So for example, if you have 2 with an exponent of 4, the base in this example is 2 and the exponent is 4. You could say this as 2 to the 4th power or 2 to the power of 4. All right, that is letting you know that this number is going to increase. That is letting you know that you are multiplying the base by itself 4 different times. So in this case, you have 2 times 2 times 2 times 2. So you have 2 times 2 is 4, 2 times 4 is 8, 8 times 2 is 16. All right, so any natural number, positive integers from 1 to infinity, they are called power. Now, there are a few exponent rules that we are going to follow. Today, we are going to focus on a few, not all of them. So this video is going to be part 1 of understanding exponents. Now, the first one is the product rule of exponents. So basically what it says is when multiplying the same base, that base could be a number, a letter, or a symbol, we keep the base and add the exponents. Let me say that again. When multiplying the same base, we keep the base and add the exponents. That is the product rule of exponents. So for example, if I give you 7 to the 3rd power, multiply by 7 to the 5th power, my base is the same. Therefore, my base is 7. I am multiplying. Therefore, I'm doing the product rule. So I have to add the exponents, 3 plus 5. That equals to 7 to the 8th power. All right, so whenever we use the product rule, we have to make sure that we look at the same base and then add the exponents. So keep that in mind. That is the key word right there. It has to be the same base. All right. I have 4 examples for you to try on your own. I gave you numbers and variables so you could practice how to actually apply the product rule. So take a minute, complete it, and we're going to move on with the video. All right. So my first example, I see my base is 2. So I know I have the same base and I'm multiplying. Therefore, I keep the same base and I add the exponents. 3 plus 4 gives me 7. So my first one is 2 to the 7th power. Look at the second example. My base is the variable x. I'm multiplying x to the 5th power by x to the 7th power. I keep the same base. I add the exponents. So x, 5 plus 7, that gives me x to the 12th power. If you look at the other example, I have 3 squared times 3 to the 5th power. Same base again. I keep the same base as 3. I add the exponents, 2 plus 5, and that gives me 3 to the 7th power. And last but not least, I have a variable of a. Okay, a to the 4th power multiplied by a to the 2nd power. They're the same base. That means I have to add the exponent. So a to 4 plus 2, which gives me a to the 6th power. All right, so that is the main idea behind the power rule. You have to have the same base and you have to add the exponents. All right, later on, you're going to see some little more challenging problems where your exponent is not always going to be a positive number. So keep that in mind. All right, negative exponents. All right, and negative exponents indicates that we must do the reciprocal of the base. All right, that's what a negative exponent is telling us, that we have to do the reciprocal of the base. What does that mean? All right, whenever you do the reciprocal of something, you are basically dividing the number 1 by the base. All right, so you're basically creating a fraction. You are dividing the number 1 by whatever the base is. All right, once you do that operation, the negative exponents disappear and it becomes positive. All right. So for example, if I wanted to do the reciprocal of 5, that will be 1/5. You divide 1 by the base. So that's what happens whenever you are doing the reciprocal. All right. So once the reciprocal is done, the negative sign drops and you keep the exponent. Okay. The exponent doesn't go away. You keep the exponent, but the negative signs drop. Before I move to the next slide, try to do this on your own. 2 to the negative third power. What do you think that's going to equal to? All right, 2 to the negative third power. The base is 2. The exponent is -3. Since we have a negative exponent, we know that we have to do the reciprocal. So 2 to the negative third power becomes 1 divided by 2 to the third power. If you notice, from this step to this step, the negative sign drops. All right, as soon as we do the reciprocal, the negative sign did its job. That is what the negative sign is telling you. I have to do the reciprocal, therefore it drops. And then I will follow the order. 2 cubed is like saying, it's the same thing as saying 2 times 2 times 2. So 1 divided by 2 times 2 times 2 is equal to 1 divided by 8. All right. So 2 raised to the negative third power is equal to 1/8. All right. So I hope you're seeing how the reciprocal works and how the negative exponent is actually telling you what needs to happen next. So keep that in mind. All right. 3 practice problems. I'm looking at problem number 3 right here, which is going to be a challenging one. All right. So keep that in mind. All right. I have 4 raised to the negative third power. I have the variable a raised to the negative second power. And then I have 1/2 raised to the negative fourth power. Okay. Pause the video. Try it out. We're going to go over it in a second. All right. Ready? Okay. So 4 to the negative third power, we know that we have to do the reciprocal, which means we have to divide 1 by the base and the exponent. Therefore, 1 divided by 4 cubed, all right, becomes 1 divided by 4 times 4 times 4, which is equal to 1 divided by 64. All right, we got rid of the negative exponent. It became positive when we did the reciprocal, and then we do the operation. 4 cubed is 4 times 4 times 4. Therefore, that is equal to 64. All right. A raised to the negative second power. Again, to get rid of that negative exponent, we have to divide 1 by that value. So 1 divided by a squared. There's nothing else we have to do. Either you could leave it as 1 divided by a squared, or if you have a multiple choice, 1 divided by a times a will also satisfy your solution. All right. But 1 divided by a squared is the simplest form. And last but not least, remember, 1 divided by 2 to the negative fourth power. It doesn't change. Whenever you have a negative exponent, it means you have to do the reciprocal. When you do the reciprocal, it means that you have to divide 1 by the value. Once you do that, the negative sign disappears. So look, I end up with 1 being divided by a fraction. I know you remember this from 4th or 5th grade. All right, when you divide by a fraction, don't forget your keep, change, flip. I know a lot of you remember this from 4th, 5th grade. Keep, change, flip. So instead of when I divide 1 by 1 and 2/4, it's like saying 1, keep, change the sign from division to multiplication, and then flip. Flip the denominator to the numerator. So I have 2 to the 4th power over 1, which is equal to basically 2 times 2 times 2 times 2. In this case, it will be 16. All right. It's very important that you understand, to get rid of that negative sign, you have to do the reciprocal. That means you have to divide 1 by the value that's shown. Okay, I hope that helped. All right, the next rule that we're going to target is the quotient rule of exponents. All right, when dividing the same base, and I repeat, it has to be the same base. It could be a number, a letter, or a symbol. We keep the base and then we subtract the exponents. All right, obviously we know that multiplication and division are inverse operations. Therefore, the opposite has to happen, right? So if when I multiply, I add the exponent, the quotient rule is telling me when I divide, I have to subtract the exponents. For example, if I have 4 to the 5th power divided by 4 to the 3rd power, is the same base, which is 4, then I have to subtract the exponents, 5 minus 3, which gives me 4 to the second power, which is equal to 4 times 4, which is basically 16. Okay? Please do not confuse the quotient rule and the product rule. They are two different things. They follow different standards, so make sure you understand this as well. All right. Again, let's practice these values. There's 3 problems here. Simplify them. See what you get. Pause the video and see what you get. All right. Ready to go. If you notice, 3/4 divided by 3/9, same base. Subtract the exponents. 3 raised to 4 minus 9. We know that 4 minus 9 is -5. Now we have a negative exponent, so we have to apply, right, the negative exponent rule, which is we have to divide 1 by the value to get rid of that negative exponent. So I have 1 over 3 to the 5th power as my final answer. All right. Now I have x to the 6th power divided by x to the 4th power. Same base. I know I have to subtract my exponent, so 6 minus 4 gives me 2. So my final answer is x to the 2nd power. All right. And here I try to trick you. I have -2 raised to the 5th power, -2 raised to the 3rd power. The base is not changing anything in the exponent. All right. My base is still -2. All right. So I have -2. And then my exponent, I'm dividing, I have to subtract my exponent, so I have 5 minus 3. All right. So -2 is equal 5 minus 3 is 2. So I have -2 raised to the 2nd power. Now, that means that I have to multiply -2 by itself twice. Therefore, when I multiply -2 times -2, we remember from back in 4th, 5th, 6th grade that negative times a negative gives you a positive, and 2 times 2 gives you 4. Therefore, this value is 4. The key point here is we do not mess with the base. We keep the base as is. After we work the exponents, then we see if it could be simplified a different way. Okay? All right, there's another rule that we have to remember, which is the zero exponent rule. Now, basically what this is telling you is that any number raised to the 0 power is equal to 1. Any number except for 0. All right, you cannot have 0 raised to the 0 power. You cannot make something out of nothing. So any non-zero number raised to the power of 0 is equal to 1. Now, this explanation derives from the quotient rule. Okay, now we were taught a long time ago when we started multiplication and division, 3rd grade, right? We were told that if you divide a number by itself, the answer is always 1, right? Now, we were told anything you divide by itself is equal to 1, but we were never told why. The quotient rule tells us exactly why. For example, if I divide 5 by 5, I get 1, right? If you use the quotient rule, we know that 5 over 5, if the number doesn't have an exponent, we know that there's always a 1. So 5 to the 1st power divided by the 5 to the 1st power, same base. The exponent, you subtract the exponent, 1 minus 1 gives you 0. Therefore, 5 to the 0 is equal to 1. Anytime you divide the same values with each other, the exponents are going to be the same. Therefore, you are canceling them out, and it's equals to 1 because the total exponent, the sum of the exponent is going to give you 0. All right, that's why when you cancel something out, you get it's equal to 1 when you're doing division. All right, so keep that in mind. Now, mixed rules. When you have mixed rules, you have to make sure that you simplify what you're dealing with. Do not try to do this in one shot. Not yet. All right, this is the introduction to exponents. Therefore, we want to take it little by step by step, little by little. So when you get something like this, I would recommend that you start with the numerator and then the denominator. We're going to tackle one at a time until you're ready to just do it in one shot. All right. So step 1, simplify the numerator and then simplify the denominator separately. Do not do it at the same time. My first recommendation will be separate the bases. See if you have any bases that are the same. In this example, we know that the 2's are the same and the a's are the same, both the numerator and the denominator. Therefore, I'm going to separate all my 2's. So I have 2 to the 8th power. I have 2 to the -5th power. I have 2 to the 3rd power. So I'm putting them together so I could see them. Then I'm going to put my 8's together. 8 to the 3rd power times 8 to the 3rd power times 8 to the -2nd power. That's in the numerator. In the denominator, I'm going to do the same thing. 2 to the 10th times 2 to the -2, and then 8 to the 7th times 8 to the -7. Now, when I separated all my values here, I could actually find the same base, and then I could do my rules. I could apply my product rule or my quotient rule, depending on what I'm dealing with, right? If I take a look at this, I know that my base of 2 Since I'm multiplying the numerator, I have to add the exponent. So I have 8 plus negative 5 plus 3. Same thing happens with my variable a. I have a raised to the third power plus 3 plus negative 2. In the denominator, I have 2, 10 plus negative 2, and I have a of 7 plus negative 3. All right, remember, when you are adding a negative, when you are adding a debt, if you're adding a debt to your life, you're basically taking away from your total amount. All right, anytime you add a negative, you are adding to your debt, you are subtracting from the total. That's why when you are adding a negative, it actually becomes subtraction. You are adding a debt to your total. All right. So again, we know that we can just drop the sign when you add a negative, it's the same thing as same subtraction. So you have 8 minus 5 plus 3. And then you have in the denominator 8 minus 10. You have in the numerator here, you have 3 plus 3 minus 2, and you have 7 minus 3. All right. Again, you follow your order of operations. We know that addition and subtraction are interchangeable, so we have to go from left to right. So I will do 8 minus 5 plus 3. In this case, I will do 3 plus 3 minus 2. In this case, I'll do 10 minus 2. And in this case, I'll do 7 minus 3. All right. So right now, once I do this, I simplify the numerator, end up with 2 to the 6th power and a to the 4th, and the denominator, 2 to the 8th power and a to the 4th. I cannot do anything else to the numerator. I cannot do anything else to the denominator. They're not like terms, so they do not have the same base in the numerator. I cannot do anything between the 2 to the 6th power and the a to the 4th power. Same thing with the denominator. The 2 and the a are not the same base, so this is in the simplest form for the numerator, and the denominator is in the simplest form. Once I simplify my numerator and denominator, then I could actually apply my quotient rule. So my step number 3 will be apply my quotient rule. If I find my same bases, I know I have to subtract the exponents. All right, so 6 minus 8 gives me negative 2. 4 minus 4 gives me 0. I know that anything raised to the 0 is 1. And I know to get rid of that negative, I have to negative 2, I have to do the reciprocal. Therefore, I end up with 1 over 2 to the 2nd power, and that's equal to a quarter. So that problem just became 1/4 or a quarter. All right, so keep that in mind. Take it step by step. That way, if you make a mistake, you always go back and revise where you made that mistake. Okay? All right, practice these 3 problems on your own. Now, I'm starting to add some numbers there so you can see that you still have to do your math operations. Okay? Take a minute, pause the video, and try them on your own. All right, we're back, right? So if you take a look at the first one, 21x to the 7th power, 7x to the 5th power. I have my numbers, 21 and 7. I could just do the operation. 21 divided by 7 is a simple math operation. Then I have x to the 7 and x to the 5th. Since these are the same base, I will apply my quotient rule. So we know that we have 21 divided by 7, and we have 7 minus 5. We know that 21 divided by 7 is 3. We know that 7 minus 5 is 2. So our final answer, our simplest form becomes 3 times x to the 2nd power. Take a look at this one here. I am multiplying. I have my numbers here. They're not the same base. Therefore, I could just do my regular operation, 4 times 5. And then x is the same with the other x. So I apply the product rule, x squared. I know that when I do the product rule, I have to add the exponent, but I have to be mindful this negative 5. So then I go 4 times 5, and then x of 2 plus negative 5. We know that 4 times 5 is 20. When you add a negative, you're adding debt, which basically you are subtracting. So I have 20x 2 minus 5, which gives me negative 3. That is not its simplest form. We cannot have a negative exponent. Therefore, we know that we have to do the reciprocal of the value with the negative exponent. Not the 20. The 20 doesn't have a negative exponent. If you have to put an exponent in 20, it would simply be 20 to the 1st power. Only x is raised to the negative 3rd power. So only x has to follow the rule of doing the reciprocal. All right, 1 over x cubed. So my answer becomes 20 over x cubed. Please understand that you are not moving everything here. My coefficient of 20, that does not go anywhere. That is not changing. You're not doing the reciprocal of 20 because 20 is not being raised to a negative exponent. All right. All right, last but not least, this is the big one. All right, I have my numerator, 32x cubed times 2x squared, x to the 4th power. I have my numbers. They're not the same base, so I will do the operation, 32 times 2. And then the x have the same base, so I'll do x 3 plus 4. We know that 32 times 2 is 64. And x 3 plus 4 gives me x to the 7th power. In the denominator, I have 4 cubed So that's x to the negative second power. 4 cubed is saying 4 times 4 times 4. We know that 4 cubed is 64 times x to the negative second power. I do not have to keep going. I already simplified my numerator. I have simplified my denominator. Now I will apply my quotient rule. The numbers 64 and 64, they are the same base. All right. We already know that when you have exactly the same thing, they cancel out. But that will be 64. If you want to put an exponent of 1, that's just doing extra work. We just cross them out. And then we end up with x to the 7th power and x to the negative second power. All right. My quotient rule tells me that when I'm dividing the same base, I have to subtract the exponents. Therefore, I will have 7 minus negative 2. Recall, when you're taking away the negative, think about it. You're taking away negative from you. You're taking away the negative. That means you are adding. It turns into a positive. You are gaining something. It becomes addition. So when you are taking away a negative, you're taking away that, you are adding to your total. All right. Therefore, you will add 7 plus 2, and the final answer is x to the 9th. I know I'm giving you a lot of information, but please take your time, pause the video, rewatch the video, because exponents are very important, and we're going to need them when we are talking about scientific notation. And when we do arithmetic with scientific notation, this is the foundation that we need. All right, and this is your challenge for next video. All right, simplify this expression. I have 4x to the 5th, y to the 3rd, times 6x to the negative 5, y to the negative 5, divided by 2 cubed times x squared times y to the negative 4. All right, try it on your own. Next video, we'll review it, unpack it, and hope you got it right. Thank you for watching the video. Take your time. All right, this foundation is going to help us be better mathematicians in the future. So please make sure you try it, and try it again. If you have any questions, don't hesitate to put in the comments, and I will see you next video. See you, everybody. Have a great day.